Hybridization of orbitals is the mixing of orbitals in an atom to produce another orbital or other orbitals that are different in shape but are disposed, are better disposed to chemical reaction. They are different in shape but are better disposed to chemical reaction. For instance, we have been able to study and know the different shapes of orbitals. So for the p orbitals, we saw the arrangement, the alignment of the p orbitals. The alignment, the arrangement of the p orbital. Now, the p orbital, according to the contributions of Pauli's exclusion principle, Albert's rule, and the Horn's rule. So we have been able to see this arrangement of atoms in these orbitals. Now we are not looking at hybridization of orbitals. How this, when we mix this orbital, the s orbital or the p orbital and a particular energy level. For instance now, if I have carbon, we have this. Carbon, we have this. We have carbon is 2, all right? We have 2 what? 4. And carbon is what? 1 S2, yes. 2 S2, yes. And what? So the remaining one is what? 1 S2, yes. 2 S2, yes. And 2P4. Sorry, 2P2. That is the the subsidiary electronic configuration of what? Carbon. This carbon, for instance now, if we have a covalent bonding that exists between the molecule of methane, for instance, methane. Now, the valence electrons that are actually available for bonding is these two, which according to Pauli's exclusion principle, that you see, for bonding to take place, pairing with for an electron will occur singly first before pairing will occur. At the ground states, the bonding is only exhibited by the valence electron, which is this. At the ground states, you have this 2s2, 2p2 at the ground state. At the ground state, this is what will occur. Now, for the 2s, we have this. We have this for the 2s. For the 2s orbital, this is what we have. For the 2s, we have 1, this spin up. Then for the other 2p, for the 2p orbitals, we have this 1, 2. For the 2p orbitals, we have this. What we have actually is this. We have this. We have this. But what happens to this? This p, x, py, pz. What will now happen? What will happen now is that they will now spread out. When they spread out, you are going to have this. They are going to have this. What you have is this. They are going to have. So now, what will happen is that when they get to the excited state, at excited state, what we have is this. So you are not going to have this at excited state. At excited state, so now the 2s having this, we only have 1 electron. The 2p having this, the 2s orbital, the 1 electron of 2s orbital will be pulled, transferred to this. We have this, we have this. So now, this is what now obtains. By implication, it means that you now have an sp3. So methane, that's how methane attains the sp3 hybridization. So meaning, the one of the electrons is pulled to this vacant orbital, while this one comes to this place to occupy this. So that's how we have the sp3 hybridization of methane. Now for alkenes, we have sp2. Alkenes, sp2. So alkenes, e.g. alkane will have sp3. Alkenes, we have what? sp2. Then alkynes, we have what? sp. That's all. Thank you.